Hello, 8th graders. We're going to go through something that we've done in 7th grade, but I would highly doubt you to be able to remember all this stuff. But I'm hoping that the background we had last year will make this a little bit easier. So, like I always said, remembering is easier than learning. So, we're going to be working on volume of cylinders and prisms. And if we want to remember volume, volume will always be the space inside of a shape. So, sorry, I got to clear my throat there. This shape on the left here is a cylinder. It's a very large cylinder and it goes up a circle on top, circle on bottom. A Rubik's Cube is a square prism or rectangular prism, and an X box is also a rectangular prism. Three-dimensional objects, but made of rectangles, whereas this is made of circles. So, a rectangular prism is drawn like this. There's the height up here toward the top, the base on the bottom, and the depth, or what I will sometimes just simply call the 3D measurement, because depth changes. Depth in a pool is going down. Depth for a pyramid is going up, and depth for a rectangular prism is going back. So I'll just sometimes say the three-dimensional measurement. Well, the way to figure out the volume is pretty simple. It's going to be the area of one face times the depth. So the easiest way here is to find the area of this front face here, which is a rectangle with an area of base times height, times the depth in the back. Now that could also mean you could find the area of this face here, which would be height times depth, and then multiply it times base. But you'll frequently do the front one. Which means volume is given to you as this formula. Base times height times depth, where base times height is the area of the front face. So you need to have both of these written down. Very important formulas. I will not require you to memorize these formulas, but they are important to know. So let's move on. A rectangular prism on the top here is this Rubik's Cube, which means it's made of all squares. So the bottom measurement's 3, that means this measurement's 3, that measurement's 3, and so on and so forth. The bottom measurement here is 3, meaning that measurement's also 3, and so on and so forth. And up here, the measurement's also 3. So we have to do, the volume is equal to this front face, the red face, times the depth. Well, the red face is simply going to be 3 times 3, and I'm just going to put little brackets around it to show the difference here. And the depth is going to be 3 as well. Now, you could have just written this as 3 times 3 times 3. That's fine, too. So our volume would end up being 9 times 3, which is 27, and we're going to go inches cubed. Volume has to be done in cubed because you're multiplying 3 things together. Okay? So here, on the bottom, we have a rectangular prism with a base of 4, a height of 4, and a three-dimensional measurement, or depth, of 6 meters. So that means if we took out our little picture, we'd have to draw it. Now, I'm not going to be great at this, so I apologize. But it'll look something like that. That means that the base will be 4, the height will be 4, and the depth will be 6. Once again, we have to find the volume of the front face here, which is 4 times 4, times the depth, which is 6. 16 times 6 is going to be 72, but we have to do meters cubed. And so that's it for rectangular prism. All right. So I'd like you to try this one on your own. Find the volume of the X box. You may use a calculator. Alrighty, so I hope you tried that one. The volume is going to be pretty simple. It's just going to be 18 times 5 is going to be the area of this front side of the X box, and the 8 is going to be the three-dimensional measurement. So you just do 18 times 5 times 8, which if I pulled out the calculator and got it to work, stop, there we go. 18 times 5 times 8 gives us 720 cubic centimeters. And that right there is the volume of the Xbox. Alrighty? So let's move on to triangular prisms, which are very similar. Once again, you have to find the area of the front face times the depth. Well, in a triangle, the area of this front face right here is a triangle. Therefore, the formula is going to be a little different. You have to do 1/2 base times height, because it's a triangle, and then times the depth. Okay, so the volume of this one here would be 1/2, oops, times 10 times 8, or I did height times base, times our depth of 15. So if I do this first, doesn't matter, I'd get 40 times 15, which is 600, meaning the answer to this is 600 cubic feet. So now I want you to pause it and find this area of this Toblerone thing here. Now, this measurement down here at the bottom we can erase. We don't need this 2 here. Okay? We just need the height, the base, and the depth. So give this a try and see how it goes. Okay, so we're back. This one shouldn't have been too bad. It should have been volume is equal to 1/2 times 1 times 3 times 10, which should have been 15 cubic centimeters. If you have any questions, bring them to class tomorrow and I can help you work through them. Okay, so on our last set, so the volume here of a cylinder is going to be the same as the volume of a prism, except that now if you see here, the volume of the front face is a full circle. Whoops. Come on. It's a full circle here and here. Therefore, in order to find the area of the front face, we have to do the area of a circle, which is pi times r squared. And then we have to do it times the height, or this can also be called the depth. That's that three-dimensional measurement. It's going to change based upon every figure you're looking at. But you have to find the area of the face or the base times that 3D measurement. So here, the diameter is 4, so the radius has to be 2. So I would go pi times 2 squared times the height of 8, which would give me 4 times 8, which is 32. So I would get 32 pi. And I would go inches cubed. Or I could go 32 times pi. Get an answer of 100.5 about. Either one of these answers would be acceptable. So now I want you to find this silo down here. I want you to find the volume of the figure. Okay, so I'm going to pause it and have you do this one. Okay, so this shouldn't have been too bad. If the radius is 12, it should have been volume equals pi times 12 squared times 40, because that's the height. So we have to pull out the old calculator. 12 squared times 40 is 5,760 pi feet cubed. And that times pi is about 18,096. Alrighty, bring questions you have to class tomorrow. We will be doing these 11 problems in class. Alright, we'll see you tomorrow.